The last aspect of descriptive statistics that I want to discuss is correlations. Correlations are a different type of measure that allows us to look at the relationship between two variables. It doesn't explain cause and effect, but it says how two variables are related to one another. And often the measures that we take are related to one another. In fact, they can often be so related that if we know one, we can predict the other. So that's what correlations are. They allow us to evaluate the relationship between different variables. So let's take a closer look. So correlations describe a non-causal relationship between two variables. So it isn't saying that one variable necessarily causes a change in another, but it does say that there's a relationship between them, and that therefore the one variable potentially could be utilized to predict the other variable. Typically, correlations include a directionality and a strength of the relationship. So we look at, is it a positive or negative relationship, or is it a strong or weak relationship? Correlations are positive when one measure goes up, the other number goes up, or they can be said to be negative, that when one number goes up, the other number goes down. So let's look at some examples, and these have nothing to do with our field, but they, again, just kind of show examples of this. Typically, correlations, again, they're two different measures that you're taking, and they're shown typically on a graph, where, again, you have along one side of the graph the one variable, and on the other side of the graph a different variable. So in this example, what we have are temperature. So this is outside temperature, and maybe these are different months of the year. And then how many heaters were sold in a given month. So more heaters is down here, fewer heaters here, low temperature here, high temperature here. So if we take a very hot month, let's say that's this month here, we see the temperature's high because the dot is up towards the top, but then the heater sales are very low. When we go to another month, not quite as hot, heater sales are a little higher, another month, and so on. We get to a really cold month, we see heater sales are through the roof, right? So that's considered to be a negative correlation, because as one measure goes up, the other measure goes down. So this is a negative correlation. It's considered to be a strong negative correlation because if we connect the dots, it's very close to a straight line. So that means that it is very significantly correlated, meaning I can very much predict if it's a real hot month, I can be very confident we're going to not sell many heaters, versus if it's a very cold month, we're going to sell a lot of heaters, right? So that's an example of a very strong negative correlation. Positive correlations are going to go the other way. And again, I think of a positive correlation is if we were to ask all of your athletes, all of your clients, their shoe size and their height, what kind of relationship would you see between shoe size and height? Would you see a positive correlation or a negative correlation? Well, I would hazard to say that, again, in general, the people with bigger feet are also going to be taller. So we're going to see a positive correlation between those two measures, and we're probably going to see a fairly strong relationship. Now, there are some people that are very short but have very big feet, but they're fewer and further in between than the people who are tall and have big feet. So again, that would be an example of a positive correlation. This is another example here. What we have here is advertisements seen and their person's goal or intention to purchase whatever it is that was advertised. And if we chart these different things, we see kind of a cloud, right? But in correlations, what they'll often do is draw what's called a line of best fit. A line of best fit will try and see, hey, what is the line that fits through here the most clearly? And we could see if we did draw a line, it probably would be something along my pointer, right? It heads upwards, so that's a positive correlation, meaning as one thing goes up, they see more advertisements, they're more likely to want to buy something. But the dots aren't all along that line. They're pretty spread out. It's kind of like a cloud. So that would be considered to be a positive correlation, but a weak correlation. So we can't really be real confident that if a person saw a lot of advertisements, that they actually wanted to go out and buy something. So those are examples of the terms positive and negative correlations, and also an evaluation of the strength of the correlation. Now, we often will graph them and show them in an article, and you can take a look at that. They'll usually put the line of best fit there for each one, and you can see how well they follow along the line of best fit. But there's also a statistical way to measure the strength of a correlation. The strength of a correlation, again, if we look at these two, we certainly can say this obviously is a stronger correlation because they fit really tightly along a line. As temperature goes down, very much so does heater sales very much go up. But again, we can evaluate the strength of this correlation by calculating a correlation coefficient. Now, again, in this class, I'm never going to have you calculate a correlation coefficient, but I do want you to understand when they're reported what it means. Correlation coefficients range from -1 to +1. Okay? Negative means it's a negative correlation. Positive means it's a positive correlation. So ranges can be anywhere from -1 to 0 to +1. A 0 correlation coefficient, or numbers closer to 0, mean there's no correlation. So again, this is probably a number closer to 0. It's a positive number because it's a positive correlation. This correlation coefficient likely is very close to -1 because it's almost a straight line, showing that it is a negative correlation and a very strong correlation. So again, positive correlations. So when you read the research and they talk about a correlation between some two measures, they'll give you this correlation coefficient. It's designated by a lowercase r. Okay, so make sure you remember that. And the ranges for the R are from -1 to +1. In a positive correlation, the R score will be greater than 0 and equal to or less than 1. So it'll be a positive number. In a negative correlation, again, it's reported as an R, but the scores will be below 0 and equal to or greater than -1. Okay, so R score tells you by its whether it's positive or negative, tells you whether the correlation is positive or negative. Does it head up or does it point down? Closer to 1 is a stronger positive correlation. Closer to -1 is a stronger negative correlation. Okay, so again, if you see an R score of 0.95, that means it's a positive correlation and it's incredibly strong. The two numbers can be used very much to predict the other. So again, we get a very strong correlation. So anyway, this shows here this, and I actually have this taped to my computer because I read a lot of these studies and I can never remember how to characterize correlations. But again, if the correlation is 0.24, positive or negative, or less, so between 0 and 0.24, then it's a weak correlation. If it's between 0.25 and 0.49, that's a moderate correlation. Moderately strong correlation is between 0.5 and 0.7, and then a strong correlation is anything above 0.75. So again, that gives us an idea of how closely related numbers are and how well one number potentially can be used to predict another. We see this a lot in performance tests. I've spent some time kind of reading some articles and so on about performance testing, like the study we read earlier, or I pointed to earlier. And we often see, like at like the NFL Combine, people do the vertical jump, they do the broad jump, they do a 40-yard sprint speed. There's a very high correlation between those measures. If you're good at the 40-yard dash, it's very likely you're also good at the vertical leap. So we see fairly strong correlations between a lot of those different measures, and so on. So anyway, that's the last of the descriptive statistics that I wanted to talk about. And all of these measures that I've talked about, you'll see in almost every article. So we almost always see means, standard deviations. We frequently see correlations or correlation coefficients as well. So it's really important for you to understand what they're talking about and not just pass over it because it sounds like a bunch of mumbo jumbo. So anyway, hopefully those were helpful tips for you and hopeful tools for you. And as you read these articles, you'll become more and more comfortable reading and evaluating the statistics. Again, the content of these presentations was drawn very heavily from the Text Research Literacy, a primer for understanding and using research. And then I did reference the article by Garrett et al. That was entitled A Preliminary Investigation into the Discriminant and Ecological Validity of the Athletic Ability Assessment in Elite Australian Rules Football. Anyway, that's it for this presentation. Hopefully you learned some things about descriptive statistics and you're ready to move on.